Hi, everybody, and welcome to our broadcast today. We're very excited to be able to be sitting here at the CMTA offices with both the design and the engineer solutions team. Martin Clark has joined me today, and we're excited to be able to be here. So why don't you guys go ahead and introduce yourselves. We'll start with Chad.
Hey, I'm Chad Riggs. I'm a project manager here in the Energy Solutions Division.
I'm Zachary Snyder. I'm an electrical engineer with the design side.
And Doug Hunley, Vice President, Managing Partner of our Louisville office, mechanical engineering background.
Perfect. So thanks, guys. Martin and I were just excited to be able to sit down and just talk through, some of the great work you guys have been doing, not only here in Louisville, but across the country. So why don't you go ahead and first kick it off and explain to me, who is CMTA? Who wants to take that?
Well, I'll start. I'm sure everybody can tell it 20 different ways, depends on who you ask. But we used to say, CMTA, we were used to be CMTA Consulting Engineers. Quite a few years ago, we realized we did more than just consulting engineers, so we've just became CMTA. And, we use the phrase building science leadership because we do so much more than just engineering. We want to be involved in the front end to help with the design of the building. We want to help the owner select systems. We want to make sure they're getting the product they want. We want to help with the architectural design. Then after the building's built, we go back and we monitor the building and we track it. And so we're more than just engineers. We don't just design buildings. We live with those buildings for, years. And nationwide, I think we're 31 offices now. We're over 600 people. So we're a large firm that, has a lot of capacity and, again, do work across the country.
That's great. I love how you work with that customer throughout the whole process. Mm-hmm. And then the best part is monitoring it as well.
Mm-hmm. Yeah, the monitoring. If we're getting under the sphere, or you want to show that since you mentioned the monitoring?
Yeah, we will definitely share the sphere. Yep.
Okay. Let Chad talk about energy solutions now.
Yep.
Yeah, so the energy solutions grew out of CMTA as a whole. The data-driven company, been doing high-performance designs for a number of years. In 2012, the Energy Solutions Division was created. We saw a need in the industry for a new direction for performance contracting, a different approach. And that's what CMTA has done with performance contracting. It's very data-driven. Our guarantee is very unique to the industry. We do a lot of whole meter designs where it's very simple, straightforward for the client to understand. We do a lot of holistic renovations. It's very unique to the industry where we use our expertise in schools where we're designing new renovations constantly. We're doing that within a performance contract mechanism. So we're seeing tremendous success, tremendous savings in that industry. So it's just a substantial growth for our company as a whole.
So when we look at some of the different terminology and things that we see out there today, everyone talks about net zero, or I guess we now need to say zero energy. You guys want to talk to us a little bit about what that means to you and the role you play?
So when we're looking at zero energy, what we're saying is that at this building, we're going to produce as much energy as we use. So the different terms that have been used over time, you'll hear net zero or zero energy, but they're basically the same thing. Zero, I say the net zero ready, means that it's a high performance building that's designed to a low EUI so that a renewable energy could be added to make it zero energy. And, the argument could be made that any building could be zero energy. It's just how much renewable energy do I want to install? But we design buildings that are cost effective, very high performing, so that the renewable energy can be affordable.
That's great. I love that explanation. Well, and I think, once again, I love how not only are you looking at how you design it, but then once again, it goes back to Chad and how it's monitored and it's proven out. So I love that aspect of it. So in your opinion, what does it take to design a zero energy building? Do you want to just give some feedback on that?
Well, I'll start with that to achieve zero energy, the way we start is drastic energy reduction. We don't even start with what the renewable energy is. We first have to say, how far can we get energy consumption down? And that way, the renewable energy component is much smaller and affordable. So we'll start with the envelope. We'll talk about a big term that we use internally as we're designing buildings is cost shifting. If we're looking at true collaborative design, it's not the engineers in one area, the architects doing their thing. It's both of us working together for a holistic solution. So if we see the opportunity to improve windows or a wall so that I can reduce my HVAC system size, then it's going to be a better solution for the owner long term, and we're reducing energy costs, the renewable energy. So that's kind of the holistic approach of how we look at it.
Well, and I like that because I hear sometimes there's conflict, right? Like the architect might want something, and then the consultant might say, well, that doesn't fit within our goal. And then now you have to convince the mechanical guy to reduce the equipment based on, you know, your calculations. And if somebody's not holistically involved, that might not all work. So it's great that you have that collaboration already to get that customer where they need to get to.
And yeah, starting from, I mean, early on, you know, we want to have a champion from the owner side. You know, we want somebody on the owner side that is saying, yes, I want a sustainable building. You know, even if it's not zero energy, any building should be sustainable, but getting the owner in the front end to say they want that, even as far as whenever an RFP gets issued or, you know, for a new project, if they can get that in writing in the RFP, every design firm that is now going after that sees that that is the owner's goal. And if that owner pushes that goal from the start to finish, everybody on that team is now on board. The architect, the engineer, the contractors, the commissioning agent, you know, everybody works towards that ultimate goal of a sustainable, potential zero energy building.
Yeah. And not all projects start off like that, and that's why we can make regular projects great projects, and it's because of the data we collected. And when we bring that to the owner, it's easier for them to make a decision. They see the return on investment or the potential that, you know, this given strategy can achieve for them. So.
And that data kind of leads to, you know, I've got some information here. You mentioned about the cost shifting and the data. So we had a client locally here that was looking at doing a sustainable building. They, you know, were interested in geothermal, interested in ICF, you know, interested in all these systems, but they the false impression that all that stuff costs too much. You can't do a sustainable building for a cost-effective price. So we luckily, with our historical knowledge, with the data we had, we found a local contractor. And so we did some of, you know, did a, you know, I guess a model construction type, tilt-up wall panel, you know, all these system types, had the contractor price that. We then took our historical knowledge of a building pressure test. You know, we'd come in, pressure test the buildings, know what these different envelope types were and their leakage rate. So we had that historical data. We were able to take those two items then and size our HVAC system accordingly. So obviously the tighter the building, the more R value in a building, the smaller HVAC system. So what, at the end of the day, what we was able to show is the ICF building with the highest R value, air tightness value the best, was able to do such a smaller tonnage on our HVAC system. The cost savings that we were able to include from that HVAC system covered the minor cost addition for the better envelope type. And at the end of the day, it showed it was actually the cheapest first cost construction was a high performance ICF building with a high performance HVAC system, was least cost day one. And then you're reaping those rewards for the 30-year of that building. So if you turn that into a life cycle cost analysis, you know, it's a no-brainer that it was actually the most cost-effective way to do it by doing that cost shifting that Doug mentioned. It's not spending more money up front, same amount of money, you just choose where to spend that money more wisely.
Well, and I love where your conversation was going and the story you told of getting the data and being able to prove it out, and then showing that HVAC system, if it was downsized or a different way, it can really make up that cost difference. So you both mentioned a little bit about the building enclosure or the building envelope and the importance of it. What role does that play in getting someone to, obviously, having an energy efficient building, and then of course that zero energy? What role does that play?
I mean, it's huge. You know, my mom and dad will yell at me when I leave the front door open. You know, you don't want to, you're not air conditioning the whole neighborhood. Yeah, right? Same concept. If you don't have a tight building envelope, two things are happening. One, all the conditioned air that you're trying to keep inside that building could be leaking out of that building. Almost even worse is the opposite. If you have a leaky building and that outdoor hot, humid air is now leaking into your building, and now you have to compete with that hot, humid air in your building. So yeah, if you don't have a great envelope, you're again trying to condition the outside, and it's just not going to be an efficient building.
And I would say, you know, one of the benefits that we've seen with ICF that we don't see with other wall systems is the thermal mass. It essentially is building a big cooler, and it's just like anything. We know, you know, why do we use coolers? It's to keep things cool, or, you know, some people even use them to keep things warm. And so we can turn our buildings off sooner, they'll coast longer, so we see a big energy savings in the unoccupied mode just as well as occupied.
Well, and I think that, I love that you brought up thermal mass, because I think that is something that is kind of lost, where people are looking at the R value and they're not equating in that thermal mass aspect. So explaining it like a cooler is a great way to explain it, and don't leave it open, right? Make sure that we're closing it. So
And the resiliency, as Doug said, you know, you can shut the systems off earlier and the buildings could stay conditioned longer. You know, some of the power outages, you know, the long scale power outages that we're seeing, the resiliency is a big thing with ICF too. You know, or a better envelope of, you lose power for 2 or 3 days, that building is going to hold that heat, you know, in a cold environment, it's going to hold that heat longer than your traditional building. All the issues that you saw in Texas, you know, last winter when everybody lost power, pipes were freezing, sprinkler pipes were freezing. Not saying, you know, ICF is going to solve that problem, but it'll keep that building resilient longer than a leaky envelope would.
Gives you more time to react to the situation.
that makes sense.
So, you know, being Richardsville, being the first net zero school in the nation, and I know you all have always been out on the forefront of this, what type of issues did you run in with as far as working with the Department of Education, the school district, and the board members?
So I think, you know, starting that project, the biggest misconception was that it was going to cost a lot of money. And, you know, at the end of that project, with all the data that we had collected on previous schools that we'd done with that district and other districts, we were able to show them that we were getting really close to the point of achieving net zero or zero energy. And it really came down to is what was the renewable energy piece of this going to cost? So working with KDE was great. They were encouraging this. They wanted to see it happen in Kentucky. But there were some limitations on how could we procure renewable energy and afford it. So working with the state, we were able to develop some grants that they funded the renewable energy component of that. Because if you look at what solar cost when we did that project, I'm not going to say it was exactly 10 times the cost we're seeing now, but it was close. So it wasn't a cheap, you know, option to consider. But again, because we got the energy consumption down so low, we were actually able to achieve this with putting solar on the building. So the grant helped a lot. Second was the rate structure. Working with the local utility companies to figure out how can we make this a return on investment for that owner. We were fortunate to work out an agreement with the Tennessee Valley Authority, TVA, who gave them a special rate structure that paid for their production, that helped, you know, afford that renewable energy. And so those are some of the key items that made that project happen.
So what type of energy savings is Richardsville having? I mean, I've here they're actually getting a check back every month. I mean, so.
Yeah, that one's was specific to that project because TVA's rate structure was so beneficial. We were actually producing a little bit more power than we needed or that we were consuming, so we were net positive. So they were actually getting a check back paying. And a lot of that just, again, like if they were buying electricity at 9 cents a kilowatt hour, they might have been getting paid 13 cents a kilowatt hour for production. It was a special case. That's not what we see everywhere, but, you know, that was a great benefit to them.
And just general energy savings, you know, across the country. You know, I'd say an average energy use on an EUI or a kilobtu per square foot per year is probably at a 55, you know, for a newly built school. You know, CMTA, I'd say we have 200 plus schools that are under a 35. And our goal is typically a 25 or under is where we want to go. So we want to take a typical school building and almost cut it by half.
I would say on average, our elementary schools are operating at 20 or just a little bit above 20 EUI, so less than half of the average.
And then, you know, equating that to dollars, I mean, it's hard to say because obviously everywhere across the country pays different rates. But, you know, one of example that I have, a project we did in Houston, Texas, we took a prototype elementary that the district had built numerous times in the past, same footprint, just in the neighborhood up the road, just a mile away. So same climate conditions, same operating hours, but we redesigned it, made the envelope a little bit better, changed some details, put it in a high performance system. And after the first year of operation, that school was using about $50,000 less in 1 year. And now that school is going to be there for 30 years. So $50,000 across 30 years is a lot of money the district can now put back into the pockets of hiring another teacher or more supplies for the school. Take that savings and put it towards something that, helps the children.
Well, and then I think when you think of obviously there's these benefits, but then, we're assuming now we've got a better building enclosure, air and water's not getting in, we're not causing damage, our HVAC systems aren't constantly cooling or constantly heating, right? So all of those advantages on top of the fact that they're also saving money is incredible.
And another big thing that we've seen here recently in our recent code updates for the state of Kentucky is they added storm shelter requirements at educational facilities. ICF is a natural fit for that. So what we're starting to see is that the storm shelter component of that is being built out of ICF, and that's a huge benefit. But that was something we were already using. It was a product that people were familiar with, so it wasn't a big change, but they're getting the benefits of all of that now. It's something that it brought additional value to the project.
So from the ICF wall, with the R rating or U value of the wall, what are you all doing on the roof? I mean, are you adding extra insulation for the roof system to totally, tie the building envelope up?
So yeah, on the roof, there's a point of diminishing returns, just like anything. So we've done a lot of studies to say, how far do you take the insulation on the roof? And what we found is it's very similar to what we're achieving with the walls, in an ICF scenario of about R30. Anything above that, we're seeing a diminishing return. So, R30 is what we're targeting on a high-performance building. But again, it all comes down to how tight that roof system is. Reduce infiltration, also the color of the roof system, because unlike the walls, the roof does get a lot more solar radiation. So what we want to reduce that, keep that roof temperature down, which will also reduce energy consumption. But the biggest issue we found with roofs is how the connections are made to the wall. So whether it's a low slope roof or is it a metal seam roof, we can make the insulation value R30, but if we don't make that connection right, that interface between the wall and roof, that's where we traditionally see the most infiltration. And that's key, is getting that connected properly to achieve high-performing buildings.
He's speaking our language. I'm so excited. Both my kids interned with us, and they would make fun of me because I'd say, that roof air barrier is flapping in the breeze and it's not connected to the wall air barrier. So I definitely understand that, and it's something we should look for and address. And thank you for bringing that up. I like that. What about from a restoration perspective? I know you work with a lot of different restoration opportunities. What are you guys looking for there when you start to look at ways that you can reduce the energy consumption?
Yeah, so every project is a little bit unique on the challenges that we face. When we start a project working with a client, we walk their facilities, we analyze their utility bills. Usually the utility bills will tell us where the opportunities are. We like to address the older facilities. I think Doug has a good point. That's usually what we try to look at first, is that exterior wall roof penetration there. We often go back and apply spray foam just to seal up that infiltration opportunity in the building. We look at window replacements. Sometimes we can include roofs in our projects where we can add additional R value. We typically don't address exterior walls or insulation. It's just once a building is built, it's hard to make a huge impact in our projects. Obviously, the better the building envelope, the lower we can guarantee the EUI for that particular building. So it's something we always factor in. What kind of the building envelope are we dealing with? What's the HVAC system? What renovation are we looking at? Are we looking at geothermal or some other system type? And we have the data. I mean, I think you can tell that we have the experience. We know where these buildings should be operating. So our guarantee is pretty easy to calculate, and it's our results are proven. But it's through our tremendous data that we know, based on the existing infrastructure, what's the best system to install for that particular building, and how will that building operate.
I think that the modeling and the data, I think, is what's so exciting. You know, so for years now, over 15 years, I'm talking to people about air barriers and making sure things work right. But I don't have the data to say this is what it's actually going to do for you. And that's why I'm so excited to hear about the data collection and how you share it. It's pretty exciting.
So, talking to Warren County Schools, my understanding, Jennings Creek was actually, a lot of it was funded through, as far as the PV and energy solutions, the money was funded by ESCO. So can you explain what that means, and just explain how Warren County Schools was able to, how you all were able to do this?
Yeah, so ESCO, like you mentioned, is a short for Energy Services Company. That's what our CMTA Energy Solutions Division is. Has many names. It's performance contracting, energy performance contracting, but it's really a procurement path that allows our clients to fund infrastructure projects through the money that they're already spending, their utility and operational budget. We develop a project and guarantee operational and utility savings, and we leverage those savings to pay for a project, and it pays for itself over time. So Warren County, that was one project that we worked with one of our previous clients. At the time, we were developing a number of HVAC renovations, looking at opportunities at all their buildings for installation of solar. At the same time, our design office was designing a new building in Jennings Creek Elementary School. During that project, we also applied for a grant. So we received a grant for $375,000 to support solar PV. And we were looking for a great opportunity, a building that had a new roof. And Jennings Creek presented the opportunity where we can kind of, as they're designing a new building, we can identify that as a perfect candidate for a large solar array. It's a little bit of a unique project in Kentucky where traditionally energy performance contracting is only done within existing buildings, not new construction. So we had to go to KDE and ask for permission to do this joint effort with our design office. Since we weren't doing anything inside the building, we're only adding solar to the roof. We were able to model the baseline and incorporate that into our project. But also doing it at the same time, they were able to modify their design knowing that it was going to receive this solar to make it more cost effective. All the infrastructure was put in place during the building of the building to make sure that the solar array could be installed easily soon after the building was built.
So as far as Warren County and the ESCO, do you have any idea how much money Warren County is actually savings between the different schools?
Yeah, so back in 2018, we first looked at their building district-wide. They were operating around a 40 EUI. They were spending around $3 million in utility, around $600,000 in their operational budget. Our project guaranteed them to save $850,000 per year. On average, we're saving $1.5 million, so tremendous excess savings. To date, we're at $4.2 million total. So all that is going back into the school system, helping, improve their learning environment. And actually, the success of the project has led to a phase 2 project. So they want to use those excess savings, leverage those within a project, and fund 2 more HVAC renovations. So tremendous success.
Yes, so, from a school district or from a board member, just listening to you talk about that, I mean, that is a lot of money that is actually being put back into the school district that they can use for teachers or computer labs or whatever.
Oh yeah, and I know everyone knows the pandemic really hit our schools hard. They were actually at the time using those excess savings to purchase masks and make their schools safe. So those excess savings, were put to good use in the school district. Yeah.
So by doing this way and by building this way, as far as a healthy building or the healthy school, you know, how do you all play a part of that? I know it probably has a lot to do with the mechanicals, but
Yeah, so, I mean, even though it's a high-performing building, it's still a well building. That's something else that we take a lot of pride in, or it's also data that we collect. We personally have we have little air sampling devices that we put in buildings and look at air quality and understand how it's impacted. This building that we're sitting in now was the first office building in Kentucky that was WELL Gold certified. So wellness is something that's very important in addition to energy. When we're looking at the design of schools, we don't cut ventilation. We turn it off when it's not needed. But when kids are occupied, we're looking at the CO2 levels in this space, because the kids will perform better when they have properly ventilated buildings. So that's not something that we take lightly, and we make sure that these buildings are healthy.
Yeah, Harvard put out a study a few years ago on what Doug was talking about, the CO2 levels in a school and how many part per million of CO2 levels in an environment. They kind of found the happy medium is about 900 parts per million. That's whenever your cognitive function really starts to drop off if the CO2 levels get above that. So we've been designing these classrooms to be, I don't want to say over ventilated, but extra outdoor air, very well ventilated to benefit the students in the classroom. Well, that was pre-pandemic. Now, post-pandemic, again, Harvard has now put out studies on how you need to flush the classrooms, how many air changes per hour you need to have. So in us designing the schools that way, even pre-pandemic, now our schools that were designed 5 years ago are still a very good, healthy environment, even in a post-pandemic design, because we already had that extra ventilation built into those schools. So again, there's always ways to improve, always things to do, but it just shows that the design we've been doing for years was creating a healthy environment, even pre-pandemic.
I hear a lot about Warren County, right? It's not just happening in Warren County, right? You guys have expanded and you're working in lots of other areas as well. So talk to me a little bit about that. Does it start with the Warren County conversation or story? Or is it truly just the idea of getting to a more energy efficient or healthy building for students?
I always try to circle back to the Warren County just because that was the first. We did it there first. We did it there years ago, and that just shows that was 12 years ago now. So we've learned a lot, but that we really know what we're doing. We have become the experts in the sustainable design. But I mean, it's just everybody sees now it's the right way to design. For a healthy building, you spend so many hours indoors. People are understanding you need to design a well, healthy building. For the energy savings, utility cost, energy cost, everything are going up and up and up. So now people are seeing the benefit of designing these sustainable buildings. So I mean, yeah, we have zero energy buildings across the country now. We have Oregon, Texas, obviously here in Kentucky, the Carolinas, DC, and everywhere in between, to where it's really kind of becoming a nationwide thing.
And basically all types of buildings, my understanding from.
Yeah, we've got office buildings, zero energy. We have car dealerships, zero energy, schools, any police station. Yeah, I mean, basically any type of building has the potential, yes.
There's something interesting I would hear people say, like, oh, you're building that building too airtight. What do you think if someone says that to you? Oh, it's too airtight.
And that goes back to how we're properly ventilating the building, right? So let me control that. Don't let the building leak to control ventilation. So if I can control it, then I can make sure it's being delivered at the right temperature, the right humidity levels or moisture levels. If I can't control it, that's when we have problems. And we've seen this. We'll see mold growing on walls, especially in a humid climate. So those things we would rather control with our HVAC systems and not let the envelope do that.
That's the key word, right? Control, because then you can't remove the wall to try to get back to whatever was missed so that it's not airtight.
When you were talking about collecting energy data, could you explain how you collect this energy data and how important it is for you all to collect it, but also the owner of that building to be able to see how their building is performing?
Yeah, so I say most of our projects we collect the utility data from the utility company on a monthly basis when we don't have really sophisticated metering system within the building. Most of our high performance design buildings, we have instantaneous power meters on the building, main power feed. We have revenue grade meters on our solar production. We have individual sub meters throughout the building to monitor your lighting loads, your plug loads, your mechanical loads, your kitchen. And when we have that kind of sophisticated metering system, we can pull that into an energy dashboard and use that data for ourselves, for our own education, and also for the teachers and the schools and the students can look at that system and help monitor their building's consumption.
So I see you have an energy dashboard up there on the screen. Could we possibly go through this here and just maybe show some live data?
Yeah, we can. And this particular dashboard we developed for Warren County, but we have many other dashboards on our website. But a lot of our clients are interested in this type of dashboard. We're doing a lot of amazing things in these buildings, but the teachers and the principals want to bring that high performance design into the classroom and use the building as a teaching tool. So this dashboard was built for that purpose. So anyone can access this data. It's available to the public, and it's really was developed as a teaching tool.
Just to say real quick though, when he's talking about developed, I mean, this is something that CMTA developed. This is, when we first started Richardsville and we were looking at dashboards, we were having a lot of challenges with getting the information communicated or shown properly. So when we started developing the first net zero public school in Virginia, which was Discovery Elementary in Arlington, I think we were all in agreement that it was time to make a change, and that's where this came from. And so we developed a product that we knew was going to work with our buildings, and this is what he's going to show you.
Yeah, so the metering system that you referenced and I referred to, it's all that data is shown here, and we can monitor it by, we can look at it by the day, by the week, by the month, or the year. We have different components, like I said, in the building that we're monitoring that consumption, and you can see the breakdown of that consumption, real time. We also can see how much power the building is consuming right now, which is 20 kW, versus the solar, which it's getting pretty dark outside, so it's only producing around 10 kW. But looking at it during the day and the net energy, you can see how that power is either consumed or produced throughout the day. And all this data, you can download it to Excel. So we see a lot of our teachers using this to develop a math problem or help explain their curriculum in their particular their school. So kind of in addition to the data, there's also 360s that we captured at this particular school, this net zero school. So going back to trying to using this building as a teaching tool, we like to highlight on some of the high performance building systems that's at this school. So we like to educate students and the public about LED lighting, about geothermal, about solar. So if we can take it towards the roof. We can't really take the students up to the roof. It's not very safe, but we can give them a virtual tour to show them what's on the roof of their particular building and how that solar technology works. So they're able to take a tour of the roof, take a tour of the, witness the geothermal being built. So this is an actual, picture taking during the installation of that geothermal well field. And also take a tour of the mechanical room. So these are the centralized pumps that pumps geothermal water throughout the building. So let's see here. So we're able to All right, you want to go?
Yeah, I was just say, and each of these, as we mentioned, these are specific to that owner, to that client. So before we even begin one of these, we'll sit down with the staff, the principal, the teachers, and you'll give them a little education on what the building's going to be, and then we just listen to them on. We want to help you. You know, as a teacher, you already have way too much to do on your hands. We don't want to make this a hampering or hindering on you. We want to give you a tool that helps you. And so everyone is different. You know, as we sit down with the teachers, they'll throw out great ideas of things that we could do. And on one of these, you'll see on this one, we called it the window of the past. You know, that came out of a client that we had that we was touring them of the existing building. The building was already under construction. Then we sat down and started talking about it. And she goes, wow, this would be great if my students could see the building in this stage, you know, to see the ductwork, to see the conduit. And so we said, no reason they can't. So that's what he shows here is we was able to go in and take a 360-degree view to where the students can, you know, you can call it window to the past if you see what it used to look like. This particular client said 3D view, so that's, X-ray vision. So the students could see through the ceiling tile and see what was going on above the ceiling. We have one of them where the contractor was actually up on a ladder doing some work. There's some good ICF views. Contractor was up on a ladder doing some work and took a picture. He climbed down. We took another picture. The teacher indicated, oh, no, use the picture with the contractor. They added a hyperlink to that contractor to their CTE program in the district for skilled trade for electricians. You know, so again,
that is
just
so neat.
ideas, you know, that these teachers
Yeah.
have on this system.
I love that. I love the interaction, and I love that the 360 and then the icons that you can click on for more information. That's
And
great.
it can be virtual goggles too. You know, if a student's in a classroom, they can put on their virtual goggles and they can sit in the classroom and, you know, see those items and see those hyperlinks.
So another component of this dashboard, since this one was unique, where we're doing a performance contracting project as well, we have some 360s of their existing facilities where we went in and renovated. So not really new construction, but this is a 30-year-old mechanical room of what it looked like before our project. So we're able to capture and show the students, you know, this was, you know, what was in your school, and then what we were able to accomplish during a summer renovation. So this building was converted to geothermal over a summer. So we have different mechanical rooms, different projects that we were able to highlight within this school, and we're able to also show the district-wide energy consumption and by school what, you know, where the utility consumption was before a project, where it was guaranteed, and where it's actually performing, either kilowatt hours, kW, or natural gas consumption. So what's interesting about the district-wide summary is where it started out at a 41 EUI, you know, district-wide is now performing at a 25 EUI. So that makes Warren County the most energy efficient school district in the state of Kentucky.
I feel like even at 41, they were probably pretty good. Is that fair to say?
That is very good for a school district.
That's
yeah.
amazing. And then now even seeing that additional benefit, that's amazing.
Yeah, they didn't like being second place.
Yeah, I bet.
When we did a performance contract at another district, and I think we got them down to 33 or something like that. And I think in the interview, it was like, will you make us number one? So.
Yeah, for good reason. So, you know, obviously this could look daunting to a school district. You know, what kind of advice would you give them in terms of how would they get started looking into something like this?
Yeah, I would say we have plenty of references that they could reach out to. I think talking to someone who's been through this experience, that's seen the data for themselves, I think would give them some peace of mind. We have plenty of, I think, going to a dashboard like this to see the real data for themselves. You know, this is all straight from their utility bills. So I think.
And I think it's worth adding a scale of, you know, we've done projects as small as 3 million, but projects as large as 90 million, right? So, yeah, so I think any district, small or large, you know, they can benefit from this.
And we want to help. We don't want to add any more burden to them. So
Right. I think that's a key part, right? It's this, don't make it feel daunting, because that's what you guys are there for in terms of helping them make it through. And that was the CMTA Sphere. If anyone's interested in finding out more, you can go right ahead and get to your website and see that on there.
Yeah, and this is just our webpage that has all the dashboards that we've developed for several other high-performance designs. So each one is unique and customized to that particular project.
So, I travel all over the country promoting ICF and building high performance. And I ask school districts or ask different architectural firms or contractors. And when I ask them about, well, do you know how your building is performing, I get very few answers. So what made you all decide to do this?
Yeah, I always equate it to, okay, you're driving a car, obviously, across the country. Do you know the MPG of your car? Most people are going to say, yeah, absolutely. Why don't you know the MPG of your building? The EUI of your building is the same, question. And you're right. I mean, a lot of people just don't. They just don't think about it. They think, well, I got to pay my electric bill every month. I just write a check, and I don't even think about why it is or where it goes.
I go, mine are automatic. I have automatic
Correct,
payment.
yeah.
He's like, how much are they? I'm like, sure.
Correct, yeah. And it's just, out of sight, out of mind. But as energy costs continue to rise, people are going to start thinking about this.
Yeah, and it's not just energy anymore. I think, there's a very strong trend to reduce carbon for great reasons, especially in larger cities. We're seeing asthma cases increase and different things. So, there's a health benefit to this that's outside of energy savings, because all these buildings that we design that are zero energy, we're also carbon neutral for the most case, because if I'm generating the same amount of power that I'm using, I'm offsetting that, carbon output from somewhere else. So I think, it's maybe not just energy, but what we'll see is more people start to say, well, what can I do to reduce carbon? Because that's what, all of our college campuses have made a pledge or looking at the carbon reduction goals. And so we're starting to hear it be talked about more. We see it in our corporate, our large companies. You've seen Amazon talk about it. So everybody's figuring this out. And so it's not going to slow down. So what we've been doing was just a lead into that. And we see huge potential in this market for what we do and what we can offer.
And I think the aspect, like as you mentioned, it's just not the energy reduction, right? It's the durability and the resilience of the structure. It's the indoor air quality. It's the sound transmission, right? If we can compartmentalize, now we're going to help with the sound reduction too. So there's all those benefits all wrapped up into one. Well, and I know you brought some information here. Like, obviously, we want to refer people to your website as well, because there's a lot of great information on there. But yeah, any final?
Yeah, the website's a great resource. We have a lot of great information on there. And yeah, I mean, I just bring some information. One on some of our case studies that we've done. Third party, we're not the only people talking this. I mean, here's a report done, the financial case study for net zero energy schools, that just shows that ROI, 30-year life of a building, it makes financial sense, to do these things. So there's lots of great information out there. Obviously, I want to say, CMTA is going to do every zero energy building out there, but on one side, I want everybody speaking this language. I want more and more people pushing this, because it makes our job easier. We don't have to go in and sell sustainability if everybody else is speaking the same language. And it's the right thing to do. Every building should be going towards a more sustainable market.
The good competition, right? If
Yes.
you're on par with somebody with the same type of goals that are going to benefit.
Yep, absolutely.
So Zach, I know this is off the subject a little bit. You're building your house with ICF. Why did you choose ICF to build your home?
Yes, sir. Yeah, we've been looking at it for 2 or 3 years. We've been planning to build a new house. Was going back and forth on, I guess a few reasons. One, the financial, aspects of it. Okay, did it make sense from a first cost? Did it make sense from an ROI, from an energy use, from the resiliency? I live in southern Indiana. Tornadoes are a concern, where I live. So obviously the resiliency of an ICF house. So once we started to weigh all those options, it started to make sense. The cost of lumber, as everybody knows, has gone up drastically. So that offset the first cost. Energy use keeps going up, obviously, so designing an ICF house, I'm going to be very energy efficient, so my utility bills are going to be less. And then again, tornado-prone area, I don't have to worry about running into the basement. My whole house is is concrete. So yeah, we actually just broke ground about 6 weeks ago on it, and so yeah, we're moving right along, and hopefully in another month we'll be able to have a roof over our roof over the project anyway, and actually see the form come to life. But yeah, it's been a fun process working with it, and thanks to Nudura, they've been there along the way, and give a plug to my builder, who we've worked with before. Daniel Werner with Werner Homes has been great. Myself, Martin, and then an architect that we had, a friend out of Houston, Texas, Morse Architecture, Russell Morse. We had some great conversations early on. As I mentioned, we do this on our commercial projects. We want the engineer, the architect, the building owner. We want everybody in day one. We had a similar discussion starting a year ago between myself, Martin, my architect, my builder. We all kind of got on the phone and started talking about how to make this process happen in details, and the collaboration. Again, we do it in we do it in our daily work life, and doing that in my personal life also.
Chad, Zach, Doug, thank you so much for your time today. It was really great. Martin and I truly appreciate this time to be able to chat with you, discuss it, and I think this information is something that we're going to want to share, and we're going to do just that. So thanks everybody for joining us on this broadcast. If you want more information, www.cmta.com is your resource. You can always Google CMTA Sphere and get a lot of that information as well. Thank you. Thanks for watching. What did you think of the video? Leave a comment down below with your thoughts, and don't forget to give us a like. Are you interested in seeing more content like this? Hit the subscribe button to stay up to date with all our videos, and we'll see you next time.